Hey, Mike from Prep Pros here. If you aren't already familiar with me, I've been a full-time SAT tutor for over a decade. I've scored perfectly on the test myself. I've helped quite a few students get perfect scores, and I've published a few SAT math books. Now, I do have to start this video off with a little bit of an apology. I promised a lot of you I was going to get an August SAT prediction video out, but I unfortunately was not able to do so because I was swamped with summer tutoring. And I do feel bad because one of the things that I had all my summer students prepared for and I'd included in one of our most recent practice tests ended up showing up as the very last question for many students on the SAT. You may have seen a question exactly like this, and all of those students who worked through our practice test knew exactly what to do. But I'm going to make it up to you in this video. We're going to cover 10 things that you're definitely going to see on your September SAT, and I'm going to cover a few very advanced topics like this, so in case they show up on your test, you're going to be prepared to get them right. Now, the first thing you're going to see are some form of advanced percentage questions. And what I really think you're going to see this test is something relating to percent increase or decrease. This is one of the most common places that I see a lot of students struggle. So here, if we see 684 is p percent greater than 9, what is the value of p? Now, when we're dealing with percent increase or decrease, the really important concept you want to remember is if you're expressing a percent increase or decrease, it's expressed as either 1 plus or 1 minus p over 100. That's how we can express a percent increase or decrease. So if we're showing like a 70% increase, that would be the same as 1 plus 70 over 100, or this would be the same as 1.7. If it was decrease, it would be the same as 1 minus 70 over 100, or it would be equal to 0.3. So now, as we come back to apply that to this question, what we want to do is go ahead and we simply want to say 684 is p percent greater than 9. So we're essentially saying 9 times what percent increase is equal to 684. So that's going to be 9 times our same 1 plus p over 100. And then this is going to be equal to 684. Well, now we can just solve this algebraically. We get to divide out the 9. We get 1 plus p over 100 is equal to 76. We subtract over our 1. We get that p over 100 is equal to 75. Where p is equal to 7,500%. That will be our correct answer. The really common mistake is students will pick 7,600 because they will forget that they need to subtract away the 1, and they'll try to just do 684 divided by 9. That would show what percent 684 is of 9. That's a different type of question, but if you see the increase or decrease, remember you have to use 1 plus or minus that p over 100. The next thing I think you're going to see is some form of slant height question. These will come either with your right circular cones or a pyramid. Now, the slant height is this component of both shapes. So it's just this kind of side as you go through, or if it's a pyramid, it's going to be this part of any of the triangular faces. Now, when you see slant height questions, there's kind of two varieties you'll see. If you see one with the circular cone, it's almost always some sort of Pythagorean theorem question. You'll be able to figure out the radius and the height, and you do a squared plus b squared equals c squared. With our pyramids, there's a few different varieties we can get, but sometimes they'll have you solve for the height of the pyramid, and they'll have you do that by doing the same a squared, and you'll do plus b squared is equal to c squared, and that's where you'll kind of use the slant height as you go through. So if you see these important things to keep in mind, there's a good chance you may have to use Pythagorean theorem, but with your right square pyramids, the other way you can determine the slant height is if you know the area of one of these lateral faces. They're all triangles, so if you know the area of the lateral face and you know what the base is, you can do 1/2 base times height. Those are the key strategic things you want to think about. So go ahead and pause the video and see if you can work through this one. So here, it's going to be like that last variety that we talked about. We know we have a surface area of 5,198 square centimeters for this right square pyramid. So that means we know the length and the width are the same, which includes a base area of 2,301 square centimeters. What is the slant height? Well, if we figure out, since it's a square, we can take the square root of 23,104, and that will give us that each of the side lengths are going to be 152. So we now know essentially the base. So now if we can figure out the area of one of these lateral faces, that's going to let us do 1/2 base times height to solve for the slant height. So we're going to simply do that by doing our 51,984 minus the 23,104, and then we're going to divide all of this by 4 because that's going to give us for each of the 4 lateral faces. And that's going to give us 7,220. And now we can just do that 1/2 base times height to solve for the slant. So we're going to classify the slant value as x. So we will simply do 1/2 of 152 times x is equal to that 7,220. And once we do that, we will get that x is equal to 95, and that will give us our right answer. Now let's say we twisted this problem into a harder variety that is shown up on the SAT, and they ask you for the height. Well, now you'd be able to solve for the height because you would know that the slant height here is 95. You would know that this length is going to be half of 152, half of one of those side lengths. So it's going to go ahead and be 76. And then you could do your a squared plus b squared equals c squared. Your h squared plus 76 squared is equal to 95 squared to solve for the height of the pyramid. That's another variety you want to make sure you're on the lookout for. Now, the next thing you're going to see on the test is what I like to call tricky transitions. Now, these are going to be very easy to spot, and at the end of after I talk through all the advanced stuff, I'm going to talk about which answer choice is right 85% of the time. So if you're stuck on one of these on test day, which way you should guess. But you're going to be able to spot these because you'll see comma, transition, semicolon, semicolon, transition, comma, 2 commas, and then you'll often get an answer with 1 comma. Now, one other pro tip, answer choice with a single comma is always wrong for these. So we're already getting you guessing to 33% at this point. Now, when you see these questions, the first thing you want to do is ignore the transition for a second and check the type of clauses. Now, if you aren't familiar with that, we're going to talk about this a little bit more in depth later in the video. So we're going to see if we have independent clause before and after, full sentences that can stand on their own. In 2002, his work was showcased at a prestigious architecture exhibit in Tokyo. That's independent clause that can stand on its own. Now we'll look after the transition. Renderings of Tadao's work, known for their clean line, open spaces, and harmony with nature, drew significant praise from critics and attendees of the exhibit alike. Well, that's also going to give us an independent clause. So at this point, you can't use 2 commas because we cannot join 2 independent clauses with just 2 commas. If you're not familiar with those rules, once again, don't worry about it. We're going to talk about where we can make sure you learn those a little bit later. Now, what you need to understand, the difference between these 2 answer choices is where it's showing the relationship is. This one is saying the second sentence is giving an example of the first. This one is saying the third sentence is giving an example of the second. But the trick that works really well for a lot of students is simply seeing if you can go ahead and pop the for example back here. And if you read from the first sentence to the second sentence and it makes sense, that's going to tell you that A is correct. So if we say, architect Tadao Ando has gained international acclaim for his minimalist designs that blend natural light with concrete sculptures. For example, in 2002, his work was showcased at a prestigious architecture exhibit in Tokyo. Well, this does give an example of the international acclaim because it's being shown in Japan. That's how we can see that A is our correct answer. And the third sentence is not giving an example of it being showcased at a prestigious architecture exhibit in Tokyo because we're just talking about the renderings. So that's how we can tell that B is not right. Now, as I said earlier, there's an answer choice which is right like 85% of the time on these. And that is A. If you see this structure of comma, transition, semicolon, and you do not feel comfortable working through the rules or you're stuck working through those rules we talked about, you can almost always find the correct answer by guessing this way. Now, the next thing I think you're going to see is some form of tangent related question here. And so this is probably the most common variety we're going to go through. A circle in the XY plane has its center at -5, -7. So we'll kind of just draw something out so the visual is easier to follow. So we'll have our center as going to be at -5, -7. And line A is tangent to this circle at -13, -4. So if it's going to be tangent, we'll see if I can draw a nice tangent line. Yes, we can. It's just going to be touching the circle at one specific spot. So we're going to say this spot is going to be -13, -4 as we go through. Now, what is the slope of line A? Now, this is just a very specific piece of math that you want to know. What you want to know is the slope from the center of the circle to the point of tangency is always going to be perpendicular to that tangent line's slope. So all we have to do is find the slope from -13, -4 to -5, -7, and then the perpendicular is going to be that negative reciprocal. So we'll simply do our -4 minus -7 over our -13 minus our -5. When we go ahead and do that, that is going to give us that this is going to be 3 over -8. So this is going to be -3/8. So therefore our perpendicular slope will be 8/3, and that will give us our correct answer. Now, the next thing you're going to see is one of the most commonly missed types of questions, but it's also one of the easiest to learn, and this is names questions. So this is whether you should be punctuating names and whether you should be placing commas around them or before or after the name. And the issue here, like so many grammar questions for students, is they're trying to sound these out. And they feel like they can pause after biologist or pause after the name, but there's a very simple rule that I want you to follow. Anytime you see names, this could be of a person, a place, a thing, a chemical compound they've done before on the test, you simply want to look at the descriptive element that comes before the name. And if that descriptive element could refer to more than one person or thing in the world, plant cell biologist, there's thousands of plant cell biologists, that's going to tell you that that name is considered necessary, therefore you cannot place commas around it. Now, similar to the other grammar question we talked about, there's a bit of a pattern to these questions. The answer choice without commas is correct about 98% of the time. The answer choice with a single comma after the name is a very sneaky one that can be correct, but you will have to see a piece of extra information about the person afterwards. So if we said plant cell biologist Yuri Lee, a 2020 graduate, and then we put another comma, that would be okay. But when in doubt, pick that answer choice without the commas. Now, the next thing you're going to see on the test is some sort of inscribed shape question, and these give students a ton of trouble. Now, one of the really important things that you can keep in mind if you have inscribed shapes is number one, draw out a figure. I didn't draw out a perfect figure here, but it's going to let us visualize and see what's happening. And the other thing is almost all of these inscribed shape questions are special right triangle questions. So if you can use those two things, you're going to have a really good shot at working through, and you're given those special right triangles on the reference sheet from the SAT. So a circle is inscribed in a square such that the circumference of the circle touches the midpoint of each side of the square. The length of the diagonal of the square is 256 units. What is the area in square units of the circle? Now, what makes these questions look and feel really difficult for a lot of students is it feels like hard to determine anything about the circle. But if you have a circle inscribed in a square, what you always want to remember is the side length of the square is going to give you the diameter of the circle. So if you can determine the side length, you'll simply have to divide that in 2, and that's going to help you solve for the radius. So we're going to go through all the steps here now. Now the first thing is, if we have a diagonal of a square, since these are all going to be right angles here, we've now created one of those special right triangles. This is going to be a 45, 45, 90 triangle, so this will be x, x, and that means our 256 is going to correspond to the x root 2 portion. So remember, we're looking to find 1/2 of the side length, or 1/2 of x. That's going to give us our radius, and then we can solve through for the rest of the question from there. So what we're now going to say is we're going to say, okay, 256 is equal to x root 2. We want to solve for x, so we want to divide out the root 2. When we do that, we'll get that x equals 256 over root 2, and now we want to rationalize this. So we're going to multiply it by root 2 over root 2, and this will give us that x is equal to 256 root 2 over 2, or x is equal to 128 root 2. Well, that means the side length of the square, as we talked about, is going to be the side length of the square is going to be 128 root 2, but the radius, is going to be 1/2 of the side length. So that means the radius is going to be equal to 64 root 2. So now all we have to do is pi r squared, so we're simply going to do pi times 64 root 2 squared, and that's going to go ahead and that will give us our answer. So I'm just going to pop this into my calculator really quickly here. So that will give us that B is our correct answer. But important principles to remember if you see an inscribed question on your test. Almost always special right triangles, and draw it out, because once you draw it out, you can typically start to visualize the different pieces that are going to help you solve through no matter the variety. Now, the next topic is something that I 100% can guarantee you're going to see on your test, and there's a really good chance you may even see 3 or 4 of this particular type of question. So mastering these skills could easily improve your score 30 to 40 points for the standard English conventions. And this is sentence structure rules. This is how to spot independent and dependent clauses and understanding the rules that allow you to properly join them. The reason a lot of students struggle with these is they're trying to do these based off of what sounds right or feels right, and that's not going to help you get the correct answer consistently. So here we can see he was instrumental in organizing the Pueblo Revolt of 1680. That's an independent clause. As a result of his leadership, the Spanish colonizers were expelled from the region for a time. This is also an independent clause. If we have two independent clauses, there's only 4 ways you can join those on the SAT, and only one of those is present here, the comma and the fanboys. That's how we can tell that D is correct. Now, if you're not familiar with how to spot independent clauses and dependent clauses and those rules around joining them, please check out the free trial to my Ultimate SAT course. There's a whole chapter on them with many practice questions. You also can check out a free math chapter and some other advanced question types that you want to be prepared for your September SAT. You don't even need to enter in any credit card details. It's really just there to help you improve. All right, so the next thing you're going to see is probably the hardest type of reading question for most students, and these are logically completes the text questions in the second harder module. These become very complex. They often become very sciencey. It's really normal for students to tell me that they feel like they read through these 3 or 4 times and they have no idea what's happening. So there's a few tips we can use around these. The way they're making these passages really difficult is they're forcing you to connect details across multiple sentences to understand the right answer. And they're putting a bunch of scientific terms, a lot of details that make it feel really overwhelming. So as you read through the first time, the most important thing to do is to try to pay attention to connections across the sentences, or when we start consistently talking about certain aspects of things. This is going to help you start to identify what's applying to one thing and the other. And the other really helpful thing for students is to start writing down shorthand notes, because this usually becomes information overload. So go ahead and pause the video and see if you can work through this one. So here, like we'll often see, is the first sentence usually isn't going to be super important. It's just going to be background information. And now we're going to kind of get to the core of this. To understand the sedimentary processes that occurred on Titan, Dr. Megan Bloom et al. Analyzed the particle sizes found in Titan's dunes, finding that although there are isolated intervals of coarse grains, most of the sediment is regolith. And so we know, okay, there's the coarse grains, right, is isolated, and we know the regolith is, right, we're seeing most of it. So, right, most of the sediment is regolith, right? We define what regolith is, so that's always something we could kind of mentally note or write down if we want. Bloom et al. Concluded that the coarse grains are likely fragments redistributed by intermittent methane storms. So these are from intermittent methane storms, while the fine dust, which is the regolith, was deposited gradually from atmospheric suspension fields from prolonged solar events. So we know this is from RA, which, right, was from prolonged solar events. So we see intermittent methane storms here and prolonged here. So what we'll typically start to see with these types of answers is the details just start going back and forth between the two, and you have to track them. But if we've written this stuff down, it becomes a lot easier to track. This is why D is correct. While Titan's dune fields experienced episodic methane storms, right, intermittent methane storms, that scattered coarse grains, we know we're talking about the coarse grains with those, the deposition of regolith from sustained solar events was the dominant process. Well, we know the regolith is most of it, and it came from prolonged solar events. That's how we can see that D is correct. Now, if we look at C here, transient methane events, that could work for it being intermittent, produced coarse deposits in Titan's dune fields that were later reworked into regolith by continuous bombardments. We have no part in the passage that talks about a time element of one thing happening and then another. We can't pick that. B, sporadic methane events. This would be okay. Intermittently redistributed coarse material in Titan's dunes fields, though overall deposition was dominated by the settling of regolith. That all looks great. From irregular solar events, but we are having prolonged, not irregular. That's where B is wrong. A, intermittent methane storms resulted in a persistent wind system. Well, this doesn't make sense because intermittent storms, we have nothing that talks about any sort of persistent wind system, so we can strike it for that part, that mobilized coarse debris amid a prevailing deposition of regolith across Titan's dune field. So that persistent part is wrong. But the big thing with these, look for the connections, write information down. If you can do those things, you can really work through. If you're looking for extra practice with really difficult kind of passages like this and practice tests that are as difficult or slightly more difficult than the tests you'll see on test day, definitely check out our practice tests. This is from one of them. Now we're going to close out with 2 helpful Desmos tips for you. And make sure you stick around at the end of the video, because if you're cramming last minute or you need extra practice tests or other resources, then talk about some recommendations there. But the first one we're going to talk about here is how you can deal with questions with tables and equations, because these are really easy to take advantage of even when we see variables like this. So here, the first thing we're going to do is we'll simply type table, and then we're going to put these values in, negative 4k and negative 117, and then negative k and negative 78, and 2k and negative 39. And you can apply this exact same thing if you have numbers. Now, if you have variables, this is the harder variety, so I wanted to talk through this. All you have to do is define the variable. So let's just say k is equal to 2. And what's going to happen is we're going to see on a graph, we'll see points. Now, the way that we can find our correct answer is when we plug those answer choices in, whichever line or whichever equation, sometimes we can deal with these with parabolas, runs through all the points, that's going to tell you it's the correct answer. And we'll talk about, does the value of k matter or not at the end. So we'll just start checking our answers. Negative 13x plus ky is equal to negative 65. Well, that clearly doesn't work. Then we'll try our kx minus 13y is equal to negative 65. And we can see that clearly also doesn't work. So now we'll go over to our next option. So we're going to see our negative kx plus 13y is equal to negative 65k. We can see that doesn't work, so we know it's going to have to be the final answer here. But we'll go through and type it so you get to see it. So we'll do our negative 13x plus ky is equal to negative 65k. We can see it goes through all points. Now, a lot of students are like, well, what if it just worked for that one value? Always go ahead and move that slider around. When you move that slider around, it stays on the line with those points. That's your confirmation you found the right equation. And you can use this for any type of question where there's a table in the question itself or the answer choices. You can evaluate these really easily. Now we're going to close out on what looks like a ridiculously hard question. And this has not showed up on the last few SATs, so we may see it again. But the nice part for you is you actually can do this all in Desmos really easily if you remember some simple rules. So here we have the function f of x equals the x squared plus bx plus c over the x minus 8 times x minus 19, where b and c are constants, passes through the points 0, 84 over 152 and 12, 0. The function also passes through another point where f of k equals 0. What is the value of k? This just means if f of k equals 0, where y is equal to 0, so it's another x-intercept. But this is quite tricky to do by hand, but we can actually do this using the regression tool in Desmos very easily. So we're simply going to type table in, and if you get these questions, it's your job to just put in the points that the question provides. Just put in those x and y values. So we're going to put those x and y values. We'll zoom in a little bit. It's going to graph the points. Now, what we want Desmos to do is essentially plug those values in to the equation to figure out the full equation for us. Now, the way we're going to do that is Desmos is going to define the table as y1 and x1. So we will need to change all of the y's in our equations, or the f of x to y1, and all of the x's to x1. And so it knows to plug it in. Instead of a equal sign, we're going to use a tilde. So we will do y1 tilde. We're just changing this into this Desmos friendly form. Then we will do x1 to the second plus bx1 plus c. And this is all going to be over x1 minus 8 times x1 minus 19. And once we do that, it figures out what b and c are, and it graphs the equation. So we're looking for an x-intercept, right? It passes through another point where f of k equals 0. So we're just looking for the x-intercept that is not 12. So 7 is going to be our correct answer. Ridiculously difficult question if you're doing it by hand, but if we can remember how to take this equation and turn it into this regression form, this is something you can pick up points on at the very end of the second harder module in a very easy way. Now, I really hope this video has helped you out, but before we wrap up, I'm going to talk about a few additional things we can do to help you do even better on test day. Now, make sure you check out the free trial to my Ultimate SAT course. You can check out some more advanced questions like this, and you're going to learn those grammar rules. And as we talked about earlier, truly free. You don't even need to enter any credit card details. Now, if you are really cramming and you just want some last minute tips, check out this video here. It's got a great resource to talk you through a lot more common question types. If you have some more time on your hands and you want to cover all of the topics that show up on almost every single SAT, strongly recommend checking out our crash course. Now, if you're scoring really highly and you're just trying to polish off your score, strongly recommend checking out our advanced math courses or our practice tests. Those are all written to be just as difficult or more difficult than the real SAT. And if you're going to be taking the SAT again, I strongly recommend checking out our Ultimate SAT course. It's helped students get perfect scores. It's $99 a month, and it's backed by a 100% score improvement guarantee. As always, if you guys have any questions at all, drop them in the comments. Otherwise, make sure you click that subscribe button.